Hey everyone, this video is on transformations of logarithmic functions. And just a reminder that this right here is the general equation of all the transformations of any function. And that our mapping rule is always going to be xy is going to get mapped onto 1 over kx plus d and then ay plus c. So how do we do these transformations of functions? So let's take a look at this example. We're going to graph the function y equals log of x minus 1. And then we want to state the domain, the range, and the equation of the vertical asymptote. Well, for starters, when there is no base that's given to us here, it is implied that this right here is going to be base 10, okay? And so my parent function would be y equals log base 10 of x, or just y equals log of x, okay? And remember, the inverse of logs is exponential functions, just like the inverse of exponential functions is logs. So this right here, we know that the base is 10. So the inverse function is going to be 10 to the power of x. It's the exponential function. So if you remember, these are our functions without transformations right here. The first two columns are without transformations. So if my input, for example, is -2, then my output would be 1 over 100 because I would do 10 to the power of -2, which is 1 over 10 to the power of 2, which is 1 over 100. If my input here is -1, then my output would be 1 over 10. If my input here is 0, my output would be 1. And then if my input is 1, my output would be 10. So on and so forth. If my input is 2, my output would be 100, etc. So remember, these are the exponents. This is what you get when you do 10 to the exponent. Okay, great. So remember, these are inverses of each other. And because they're inverses of each other, remember, an inverse just means that you're going to swap the x and the y. So instead of -2, 1 100th, it's now going to be 1 100th -2. It's going to be 1/10 -1, 1 0, and then 10 1. Now, when I take a look at this right here, really the only transformation that I see here is this -1. And that -1 here is the d value. So here we know that the d value equals 1. And that's the only change that's really happening here. There's no k value. Well, the k value is 1. The a value is 1. The c value is 0. So essentially all that's happening here is that xy is going to turn into x plus 1, and then just y. Nothing else is changing. So if I add, and I'm doing it to this function here because this is log, the transformations are being done to a log function. So if I add 1 to 1 100th right here, I would get 101 out of 100, or in other words, 1.01. And then the y stays the same. If I add 1 to 1 over 10, I get 11 over 10, or 1 and 1/10. My y stays the same. If I add 1 to 1, I get 2. And if I add 1 to 10, I would get 11. Again, the y stay the same. So let's go ahead and graph this out. We have our x-axis right here. We have our y-axis right here. We'll put 0 here. I'm going to go by 1s on my x-axis. And then I'll go by 1s on my y-axis too. And let's go ahead and plot out these points. So 101 over 100 is pretty much 1 and a tiny bit. So it's going to look like that. And then I'm at -2. So if you notice, I'm like just a tiny bit to the right of 1. And then 11 over 10 is also a tiny bit to the right of 1. And then -1. And then we've got 2 0. And then we've got 11 1, which is over here. So this is what our function is going to look like. Now, if you remember, the vertical asymptote without transformations is always going to be x equals 0. But now, because everything's moved over 1, my vertical asymptote in this equation is going to be x equals 1. So this right here this vertical line that I'm drawing in here, this is my vertical asymptote. So now I can just connect the dots, connect my coordinates, my points right here, and I've done my graph. And then we want to write out what the domain and the range are of this function. So the domain here, because we have a vertical asymptote at x equals 0 and nothing can be smaller than 0, without transformations. With the transformation, our vertical asymptote is at x equals 1. So x is an element of the reals such that x is greater than 1. Or we could say from 1 to infinity. Either way works. And then my range is going to be all real numbers. Everything will work because my range is pretty much what and that's it for this question. Okay, so in our next question, it says graph this function right here. So before I do anything at all, I'm going to factor out that k value, which is 1/5. When I factor out that 1/5, I get a +5 right here, and then I have a +4 in the end. So now this means right here that my parent function is going to be log base 2 of x, which tells me that my inverse function is going to be 2 to the power of x. So let's go ahead and plot and figure out some points here. This time I'm going to start with -1. So 2 to the power of -1 is 1/2. 2 to the power of 0 is 1. 2 to the power of 1 is 2. And 2 to the power of 2 is 4. Because this is the inverse function right here, I'm going to write out my coordinates for the log function by just swapping x and y. And now I'm ready to figure out what my mapping rule is going to be. Well, here I know that my a value is -3. I know, and I guess I should have highlighted it here instead. I know that the k value here is going to be 1/5. And this a value of -3 is going to tell me I have a vertical stretch with a scale factor of 3 and also a flip in the x-axis, a reflection in the x-axis. This k value of 1/5 means I have a horizontal stretch with a scale factor of 5. Next, I'm going to take a look at the d value, and here the d value is going to be -5. And that means I'm going to the left by 5. And then lastly, I have my c value, which is 4. And that means that I'm going up by 4. Okay, so based on that, my mapping rule is going to be xy is going to turn into, first thing I use is 1/k. And if k is 1/5, then 1/k is positive, is just going to be 5. I do the reciprocal of it. So this is going to be 5x, and then plus d is -5. Then I do ay, which is, and we know that a value is -3, so I'm going to say -3y, and then the plus c, which is 4. And now I can apply that to all of these points that I have here. So in my first coordinate that I have here, I'm going to do 5 times 1/2, which is 2.5, or 5/2, and then I'm going to subtract 5 from that, and I get -2.5, or -5/2. And then for the y value, I'm going to do -3 times -1, which is +3, and then add 4 to that, and I would get 7. I'm going to ask you to pause the video and get the remaining 3 points, and then come back and check to see how you did. Okay, so 5 times 1 is 5, and then subtract 5 from that, you get 0. Negative 3 times 0 is 0. Add 4 to that, you get 4. Okay? 5 times 2 is 10. 10 minus 5 is 5. Negative 3 times 1 is negative 3. And then negative 3 plus 4 is 1. And then lastly, 5 times 4 is 20. 20 minus 5 is 15. And then here, negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. So here are the coordinates that I'm going to have. So I'm going to label my x and my y axes right here. I'm going to go by 1s for my y axis. I'm also going to label my x axis by 1s as well. Even though it goes to 15 here, I think the 3 points are sufficient to see what's going on, as long as I also include my vertical asymptote. So now my vertical asymptote would normally be at x equals 0, but because everything has moved over to the left by 5, my vertical asymptote is going to be at x equals negative 5. So I'm going to go ahead and draw that in to help me out with my graph. And now I can plot out my points. So the first point I see here is negative 5 over 2, which is negative 2.5, and then it's at 7. The next point I have is at 0, 4. The next one is at 5, 1. And then the next one I have is at 15, negative 2. So it's going to be down here. And I also have this vertical asymptote. So I know that my graph is going to look something like this. Okay? And I have arrows on both sides. So what does this tell me? This tells me that my domain is going to be everything from negative 5 on. So we can also just say it's from negative 5 to infinity like this. And we also know that our range is y is going to be an element of the reals. And that's it for this video. Let me know if you have any questions. Otherwise, I'll see you in class. Bye.